everybody, we're going to dive in today to some of the chemistry behind some of these tanks and, of course, the ocean. We're also going to look at some of the critters and a little bit of an update. Understanding the chemistry of ocean water is really important to, first of all, understanding how the ocean works, but also understanding how to create a habitat that's really set up well for the marine animals in your collection. So all of you know that, of course, salt water has salts in it, right? The salinity is essentially the measure of the inorganic constituents or salts in the water. And there's many different types of salts. You guys probably know more than anything sodium chloride, NaCl, which does make by weight the majority of the salts in the ocean. However, there's other salts as well, such as magnesium, calcium, phosphates, all sorts of things. And we'll get into those constituents because those smaller constituents are actually really important to marine life. So the open ocean tends to have 35 parts per thousand, give or take, 35, 37, something like that. That tends to be open ocean salinity. Now, when you start getting below 30, we get into what we consider brackish water, where usually you have some sort of freshwater influence. Maybe it's a river outflow, a lot of precipitation or rain, things like that. Now, I measure this in something called a refractometer. Now, a refractometer is a great little instrument. Essentially what happens is you put sample water on this faceplate, it bubbles up, and the light goes through the water and is bent based on the amount of salts that are in the water. And then it shoots through this prism and into the scale. And then all you have to do is take a look and you can read the salinity. So I have here 3 samples from the different tanks. My 75 gallon, the big tank, I have the 20 high and the 20 long. And so I'm gonna check out what the salinity is for each of these. Now, this other beaker is actually here for distilled water, and I always like to calibrate my instruments just to make sure they are reading correctly. So distilled water should have a salinity of 0. So we're going to check to make sure that is true. And it is just a hair off, and there's a calibration knob here. So all I have to do is do a little adjustment. There we go. And I'm right on 0. So that means I'm good to go. So I'm gonna go ahead and wipe off my faceplate with this nice little towel here. And we're going to get another pipette. And we're gonna try it out with the 75 gallon tank. Now, I record my data in a spreadsheet I've made on the computer, which is why you can see the computer sitting right there. So let's check out what this is. Oh, right on target. I am right at 30. So I'm gonna go over to the salinity marker here and we're gonna write 30. Parts per thousand is a pretty standard measurement. I'm gonna now rinse my refractometer off. So that is how I measure salinity. So pH is a really important parameter to look at in the marine environment as well as in our aquariums. And so one of the tools that I'm going to use to measure the pH within our systems is going to be a pH meter like this one. Now, pH, for those of you who need a little refresher, is essentially a scale from 0 to 14 where 7 is neutral, below 7 is acidic, and above 7 is basic. Now, essentially what we're looking at is the concentration of hydrogen ions. Now, I'm not going to get into the chemistry so much, but pH essentially equals the negative log of the concentration of hydrogen ions. The higher the concentration of hydrogen ions, the more acidic your water is, and the lower that concentration is, the more hydroxide ions you got, it's going to be more basic. Now, ocean water tends to be around 8, 8.5 or so, and that's because of the buffering power due to calcium carbonate within the system. But for now, let's look at how we actually calibrate this to make sure the meter is accurate so that we are getting, and this is from manufacturing guidelines, the 0.1 accuracy for any reading that we have on this. So I have essentially a solution that is a pH of 7, a pH of 4, and a pH of 10. And so all I have to do is go into calibration mode and move the pin from one solution to the next until it finishes checking itself against those known solutions. And then we should be able to get out into the tanks and start doing some measurements. And we're going to enter into pH 7 first and let it go. So now we're back and we're ready to go. So I'm gonna go ahead and start with the 75-gallon tank, and we're gonna put it in here and mix it around for a second and let the numbers settle out into what they are actually going to be. 7.94. All right, so now let's try the 20-gallon high. Oh, I gotta do a rinse off first. A little DO water. Now we're gonna go into the high. We're gonna look at 8.08, 8.09. All right, so that is the pH for the different tanks. Now the only tank that is really a little bit low is the 75-gallon, and that probably is because it has the most bioload. It needs a water change right about now, so that makes sense. But I also have some pH buffer that I could actually add to it if it continues to trend that direction. All right. The next thing we got to look at is temperature. And temperature I can't do in these vials because, of course, the temperature has now changed since they've been here out on the lab table. So we have to actually go to the tanks to check them. So here we are in some of the smaller systems here in my little aquarium abode that we have going on here. We've got the 20-gallon long, the 20-gallon high, and then of course down below I have the quarantine tanks as we bring things in. And interestingly enough, so over here in the long, I actually do have the Arrowhead Crab hanging out now. The Arrowhead Crab, actually I moved into the big 75-gallon tank, and the coral banded shrimp, they were a little mean to it, and I left it go for a couple of days and decided that it wasn't really good for the Arrowhead Crab, so I brought it back and gave it its own little tank home here in the lab room, which is doing well. Over here in the 20 long, I actually have the little sharp-nosed puffer that I collected earlier, and it really did well in the quarantine tanks. It started eating. It moved from one quarantine tank to the next and eventually up here to the 20 long, where it got to hang out into a more naturalistic system. It's been in here for almost a month now. It's eating, doing well, and I just may be moving it to the 75-gallon pretty soon. So let's go ahead and check out the temperature on these guys. The pen that I use to do the pH does temperature as well. But I have to do it in situ. And so it looks like the temperature of the 20 long is at 24 degrees. We're out here at the 75-gallon tank, and let's just take a look and see what our temperature is here. Gotta let it settle. It looks like it's gonna be about 25.1. And let's see, what is happening in the 75-gallon right now? First of all, I did actually get the chance to move 2 of the urchins into the tank, basically the large white pink-tipped and the white urchin. And they've been helping me out on some of the algae issues that I'm having. You can see I've got some hair algae going on, which is why we're gonna be doing phosphate next in the tank. And they have been doing a really good job, and you can see some of the clearings that they had. And of course, the coral banded shrimp are doing their thing. It was cool, I was watching the conchs do some crawling and like rock climbing, which is really kind of neat as they try and access algae, which I find very fascinating. But otherwise, everybody's doing really well, and I'm hoping to put the sharp-nosed puffer in here soon. So it is time to sign off, and until next time, keep exploring.